So up until now, we have been doing this local search. We will continue to do local search till today. Hopefully, I should be able to do done with whatever I wanted to teach today. So last class, we were looking at local search algorithm for k-median. Okay. So there are, like, if you notice in a local search algorithm for any problem, there are some basic principles that we have been trying to follow all along. And the basic set of principles was that we have this algorithm, okay, which is basically we start with an arbitrary solution. What I started with, x or s? I think it was x. Okay. I start with an arbitrary x, okay, and then I have a rule for local improvement. Okay. Okay. So any local search algorithm starts with an arbitrary solution, or sometimes, let's say, cleverly chosen solution. Okay. Cleverly chosen solution. And then there's a rule for local improvement, right? So for example, for k-median, we had swap rule, right? We said that let's swap a facility, let's delete a facility from. No. It's coming. Maybe it's not coming. Okay. Okay. So then there's a k-median swap algorithm. So this rule for local improvement will depend from problem to problem, and you have to come up with the right set of definition for swapping. And then we said, hey, no swap, return solution, right? Or rather, no local improvement. So this is a rule for local improvement, return solution. This is the common phenomena for this. So here the rule was that the rule here was for k-median was a swap rule. Swap rule was very simple, is that if there exists I prime, if there exists I in x, I prime in facility minus x, okay, such that what happens? Then we have the notion of cost, right? Cost of x minus I plus I prime is less than cost of x, then perform swap, right? This is what we did. We didn't bother about running time and everything, because in the worst case, with slightly more hard work, we can jump and do this operation. So we didn't care about this. And now what happens in the analysis? In the most analysis, in the local search, is that we always start with, say, C is my optimum solution. I don't know or we use x star, I think. Let me not use, okay. So we had this x and x star, right? This is my local solution. And if you notice, so now somehow we need to understand that why did we not do like some improvement in x star with x, right? That's a question we tried. Why some operation that brings element from x star to x did not happen, right? And again, this is not something very similar to this. It is with respect to anything, right? I have a solution, which is my local opt, and I have an opt, which is my solution, right? And I'm asking, hey, why did I not move from here to here, right? What is the reason that I did not move some object from here? Why did my swap operation did not get us? So this is my local solution, local opt. This is my global opt. My question is, why local opt is not equal to global opt, right? So that's a basic question that I would always like to ask, okay? And that is a question, if you try to answer, your everything starts to bring in. So in the local, so if you think of the way it is made here, is that if you recall correctly, last time I partitioned, okay? I partitioned, okay? I said these are the set of customers, the red buckets or the red rows are the way the elements of optimum covers, right? So this is how the elements are covered by optimum, and this is how elements are covered by like some elements are covered by. So rows represent coverage by X and columns represent coverage by X star. Okay? Okay, fine. Okay. And then the point is, of course, there is some element here, some I prime is an element here, and I prime is not here. I prime is not here, right? Because if all of GO becomes LO, then that's great. Now I want to understand, why did I not remove him? So basically, what I'm asking is that, okay, fix any I prime in your X, and you ask yourself, why did I not move I prime to this? What happens? For all I in X, I prime in X star, for all I in X, this cost function, this does not happen, right? So this is true about everything. So I would like to choose in my head, what I should I relate with respect to I prime in X star. You understand my point? For every I prime, fix an I prime in X star. Why am I not able to move? Because for every I in X, the cost function does not increase. The reason I cannot move here, because there is no element here that I can swap with. That's it. So their exist becomes for all here. Now since it happens for all Ix, right, what I know? Cost of X minus I plus I prime is greater than equal to cost of X. Otherwise, I would have made this. Okay. So the next, so this is true with respect to every I, right? So, but now I said, so if I wanted to do my computation, wanted to do my calculations, I would like to pair this guy with someone which gives me, oh, if I move this, this quantity is way more larger than cost X, because somehow. And that is the kind of reasoning people need to make it, okay? So basically what I did, like, look, I prime could have been paired with every, because still this inequality holds. But like I want to find a specific I for which I want to pair, that this inequality holds, but it tells me a little bit more. Okay. Now I start to analyze things, and I said, okay, fine. I don't know what I to do. Let's fix some I. Okay. So I fixed. So imagine that I prime is being I prime is inserted, and some I is moved out. What I am not talking about. So now what happens if I delete this I? So suppose this is my I, and this is some I prime. Okay. So what happens when I delete this? There is no. So all these people who were assigned to all these clients which were assigned to I has nobody to assign to. Okay. And now I put I prime, of course, then by definitions, but I said, look, let's not look at this. Let me look at a fixed kind of assignment. What does he does? It takes all these elements here, okay, and maps to whom? Maps to I prime. Okay. But now, and of course, these elements were mapped to whoever it is, they are mapped to whoever it is, whoever it is, whoever it is, whoever it is, whoever it is. They are mapped to. But now, what about these set of people? Whom should they be mapped to? Like, because these were originally mapped to I prime, these all were element mapped to I prime, I have mapped them, right? Rest, where do I map this? This portion, this blue portion, right? I have no clue, right? So now I have several choices. Where should I map them in, right? So what I have? X minus I prime, no, x minus I, where should I map them? Okay. So I decide to map somewhere, and they'll like, and that is where the analysis starts to come in. Hey, and that is where the choice of I will come in. I should find some object such that what is change? Now try to understand. When I do this, what is change, right? What is change? So what I mean by change? What is a change? So change is nothing but cost of x minus I plus I prime minus cost of x. This is what change is. You understand? I want to understand what is this extra quantity that comes in, because I know what is this quantity. This quantity is definitely greater than or equal to 0. Okay. So I want to understand change. Do these people provide change? Do these people provide change? No. Okay. But these people do provide me change, right? How much they were paying before and how much they are paying now, right? So this is why I said for every j here, so what is the change? So change for them, they were paying dj before, they were paying dj. Okay, now they are paying dj star because they are mapped as good as this, or if you want, this is nothing but summation d, all this like look at fix a j here. What is he paying? He's paying, how much he's paying now? He's mapped to I prime. So d I prime comma j minus d whichever guy he was mapped to before comma j. So this is the change. Yes or no? Yes. Right. So we said that this distance in optimum, I wrote, if I recall correctly, is dj star was nothing but the best. dj star is nothing but where this goes. So this is why I wrote dj minus dj star minus dj. dj is currently what they are paying here. So this is a change, but now this change should happen for everybody in this column, right? So summation over j in column of I prime. This is one change. What else? Now I have to worry about a change in this, right? So now I have to say fine, I mean first of all I have not yet decided where they should map to. Arguably they are going to be mapped to the best element here, that's perfectly fine. But I also, like anything else is anybody worse. If I can control that, then I'm perfectly happy. And that is why we came up with this idea that okay fine, it's possible for the best would have been that even if these elements somehow would have been mapped to okay, so if I would have written summation, this blue summation, j in row of I, j in row of I, and I write that also. If I could write this, it means imagine that they are mapped to the same facility which is in the optimum. Imagine, okay, imagine we map j to the facility in opt or in x star. Suppose I can, it may not even exist in my x prime, but suppose if I did, what happened? Because that's the best thing that I could have done to it, right? Okay, if I could do this to everybody, what am I getting here? What am I getting here? What is this change? What is this? This is summation. If I sum over everything, right? Each row, each column, what am I going to get? What is this going to give me? And what is this going to give me? Right? So if you notice, what is this going to give me? This is going to give me, what is summation of dj star? That is exactly what c star is. And what is this going to be? This is what my cost of my algorithm is, plus, right? Now this is over all columns, this is over all rows. So again I will have c star minus c alg is greater than or equal to 0. So what I get from here? What do I get? 2c star is greater than, wait, what does it mean? If I could do this somehow, then I will get an optimum solution. You understand, right? Okay. If, but, so this is what I'm trying to, you understand? If I could have been able to do this, then I'm great, I get opt, which is great. This is what I should expect. But the problem is, look at this guy, maybe he was mapped in x star to someone, but that someone even may not even exist in x minus I plus I prime. So what is the best thing? I said, okay, whomever you were mapped in x star, let me map the person who's closest to him in my x prime. Because at least then I have a chance of being, like, imagine I said, look, me was mapped to someone of this, but hey, this facility is not even there. Then I ask myself, what is the best for me because of this inequality, if you notice? I said, okay, but let's find out which is the closest guy to this in my x minus I plus I prime, this person. Okay, so let me map J to this, right? J to this. Okay, so this is why here what it was you were mapping it to, it was distance between nearest of whom? Nearest of sigma star of J. So which facility J was mapped in optimum solution, nearest to him, comma J. This is what I did, right? So now what I said, okay, fine, and because, so now this is great, this is still, it's C star minus C algorithm, but this is no more C star minus C algorithm, so I have to come up with some sort of bound. What is it? And then I said to you, because of triangle inequality, what we showed to you, that D of nearest of sigma star of J comma J is upper bounded by what? Dj plus 2 times Dj star, right? So I was anyway paying Dj here, right? So what is the change? What is the change I wanted? So if I was talking about J, so what if I talking about change, what will I say? This minus current payment, right? So what will I get? I will get 2 Dj star, right? So this, so now if I got 2 Dj star, I got outside everything. So what I get? So I get only one C algorithm, but I get how many? 2 C star, right? So now I get 3 C star and CL, and that was a factor 3 approximation. You understand? Okay. But notice here, in this analysis, I needed, so up until now I assumed that for everybody was paired. And now I don't know whom to pair, but I look at my analysis and I say, what should I pair him such that I am able to get some sort of bound on this function, like on this change function. Okay. So then I ask myself, what is the best we could have hoped for? If I would have been able to pair it the right people, which is an x star, then I should have got opt, which it gives you opt, right? So now what is the second best option? Second best option is, because of triangle inequality, this is what, so let me go here, because now rather than going here, this distance is smaller than this and this. You understand? Okay. So we proved this was like 2-line lemma, okay? So that was this inequality. Now in my left hand side, I need somehow C opt. But then our problem happened that, oh, so whom are we mapping to? So what was I prime? For what was this I then that we were mapping to? I prime was a facility in my current facility which is nearest to me, right? So this was nearest I prime, nearest of I prime in X. This is what it was. Okay. 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 Okay, so this is what we did last time, more or less. But now imagine that the situation becomes very bad. Situation becomes not bad or good. Situation becomes very one-earthy. Is that now if this is the function that I'm going to associate this, there could be several object or several facility in X star that they could be, say, hey, my nearest partner in X, nearest partner in X, or the nearest facility in X is this guy, same guy, right? Then each of these I am going to pair same thing. But now notice here what happens. Now what happens when I pair him, this blue quantity is counted how many times? Once. When I go this blue quantity counted how many times? Twice. When I do this blue, so if everybody goes and maps him, then do I have? So, but notice what happens. Like what happens is that if you look at here, this is not over every row, it over one row and this, but we still can't say anything. You understand? I still can't say anything after this, because what happens? Let's just try to understand that what happens because of this mapping. Okay. Imagine that everybody just maps to a singleton, same guy. What happens then? So what is this quantity? This is very good because for him, like, so what happens? So basically I fix this, this is the one. I fix this, this is the one. I fix this, this is the one. This is the one. This is the one. So it's over all columns of I prime. So this is perfectly as before. It is going to be C star minus C algorithm. Okay. But now J, this is what? D nearest C star J, right? So what happens now? Let's look at this. What are we getting? We say, oh, this is greater than 0, but everybody is counting this quantity. Okay, how many times? K times. Okay. So it is K times what? Summation over this row, right? Summation over what you call, this is, what quantity was this? The difference is how much? 2 times, yes?
So this blue row is, I prime is same, but this blue row is different every time, no?
No, suppose it does not, it is not different. Imagine that for everybody in my optimum, the nearest person is the same facility.
So in this picture that you have drawn, so left side is I prime optimal thing?
X star, yeah, this is optimum. And this is X, and this mapping is showing nearest map. Oh, you are confusing with this. This is like vertices. Okay, and this is with respect to the nearest map. I pick up an element in X star or facility in X star. I ask myself, who is the nearest of X star in X? Whichever it is, I put this edge. Right? It's possible that everybody is nearest to singleton. It's possible. Right?
A lot of columns basically are going map to the same row.
For now, I'm even saying all the rows, sorry, all the columns are mapping to the same row. Okay. Then what happens? Let's try to understand that situation.
So if one facility pays the difference,
Huh?
all others are free.
What? That's, wait, no, I'm like, of course this is bad. This is exactly what my point is. So all I can say, K into, okay, summation over J in row 2 D, what was that? D dj star. This is what I can say. This is all that I can say, right? So because everybody is going to this, so, and how many times am I counting? K times, okay? And like, so from here I'm not able to deduce or derive anything, but I could have derived like this. Look at, I can say C star C plus K summation J in row 2 dj star, right? This is the quantity, right? This is definitely greater than equal to C star minus C al plus K times summation, right? I should know, okay, summation L from L equal to 1 to K. I'm going over each columns, each what? Each rows, right? J in row L dj star. Is this fine? Yeah, this quantity is less than equal to this. Is this fine? Because what I did, I added more things here. Like I added K times for each column. If this quantity is greater than 0, then this quantity is also greater than 0. Okay, so then what does it imply? C star minus C al, but now what is this? it is k times CR is greater than or equal to 0. So what we are getting? Huh? C star. So we are getting, so if this go, so CR is less than or equal to k plus 1 times C star, which is, so this is a k plus 1 factor approximation. Right? So this is a k plus 1 factor approximation. You understand? Yes, no. Oh, there was a 2. It's okay. Yeah, so fine. So it's like 2k. You're right. It should be 2k here. It should be 2k here. It should be 2k plus 1. Fine. You're right. But that's all that I'm saying. Okay, fine. But that tells us, so it's all about, so look, what I'm saying, look at in this inequality, I have some subsets of columns, I'm replacing it with all the subsets of the columns. Okay, that's it. So this is nothing like this. Okay, so now what I did, I said there's too much weight on this, but if I can say that, if I would tell you that, hey, look at this mapping, okay, no vertex in X is mapped to more than alpha, right? No vertex is mapped in alpha, then everything will become here to alpha, like, and there will be like maybe some other set of, there will be one summation extra because those set of columns which you are mapping and not more than alpha, so 2 alpha, right, and everything will hold, right? So this is like 2 alpha, so then you will get 2 alpha plus 1 into C star as a solution. If I could do this, that's one thing. But there is one more extra property that you have never bothered about it, is, huh? Why? What is this? What is your issue? Look at this. What is this? I wrote this, right? And this is equal to what? C star minus CR plus 2 alpha times C star. It is equal. So this inequality, this is greater than or equal to this, which is greater than or equal to 0. So if I combine them, what I get? I get 2 alpha plus 1 times C star is less than or equal to is CL. So what's the problem? What's
This is also the change, right?
yeah, everything is look.
This minus the previous.
Yeah, so this were right, this minus previous. Yeah, I'm not trying to be very formal here, then that will require much more hard work. I'm not trying to be very formal, okay? But look, when can I write this? When can I write this? Why did we not do the calculation before which gave us optimum? Because we said, hey, look at look at an element here, let me map it to the best person who is mapped in X star. But that guy is not even there in my X, so that's a problem. Nearest is there, but like now we have to be careful that nearest is not going away, right? Nearest is not going away. And that's very, so look at this case, look at the I prime, what did I do here? All these people here got mapped to I prime. But look at this element, because now I am deleting I. It means this element is definitely not. What is his best neighbor? What is his nearest neighbor? Can his nearest neighbor be the one which I got deleted?
No, we would get then assigned to
Why?
If that's the case, we cannot upper bound it by 2 in J star.
I understand, but that is because
If that was the nearest, he should have been in the column.
you are at a very wrong tangent. I'm asking a very simple thing. I understand that, but like imagine I have this x and I have this x minus I prime, so I plus I prime, right? Now look at an element here, j, okay? He was mapped to whom before? Ith. He was mapped to I. Now I is not there. Whom should he map to? So I'm telling you, oh, map him to nearest of what? Sigma star j. How do you know that nearest of sigma star j is not equal to I? Why do you know this is not equal to I? How? Because if it is I, then you already deleted it.
I could have been an opt, basically. That's the thing.
No,
Yes,
it's
I-
not the question of near.
How can nearest star j be equal to I? Only another person. I itself could have been an opt.
Yes, but like why it is not the case here? This is the question which I'm asking you. Why it is not a case here?
Reason you have
Huh?
no, the reason for the exchange is because adding I prime and removing I.
That's occasional. That's not the what. I have when I make this exchange. Why? So what did I say? I said, look at my mapping. My mapping is every element goes and maps to nearest, right? That nearest is not even in this x minus I plus. Then what am I mapping to? That map is a fixed map, right? So once I have a fixed map, that is not changing. Once I told you x star and x, this map gets fixed. For every element, map him to the nearest here, right? So now, this is why if you don't go and read anything, that's not much I can do, right? I mean, this is like a story of Ramayana, which you will hear. Trust me, this is exactly what is happening in the class. These are things which are dense, right? If you would have gone and seen and read it, you would have felt it. Okay. So now let's ask ourselves a question. Okay, look at an element here. Look at an element here, j. Okay, j. Okay. So what is the sigma star of j? Can sigma star of j be equal to? Can sigma star of j equal to I prime? No, by definition. So sigma star of j is not equal to I prime, right? So sigma star of j is not equal to I prime. So what is a sigma star of j? It is not equal to I prime. It is some element, right? And what is his nearest element? What is that nearest element? Can yeah, that's a question. It cannot be. Think for a minute. It shouldn't be I. Why?
His nearest element after the exchange could be I prime. After the exchange.
What?
That person's nearest neighbor.
So from the solution we just removed I and we added I prime
Yeah?
because it reduces this cost.
No, no, no. We are not. It did not improve the cost. We are trying to. Otherwise, why will I say it's greater than equal to 0? Because it doesn't improve the cost, right?
Sorry, yeah. The reason we didn't do an exchange, this is a lower.
Yes, but that is not the point. That is not where we are at all. Here we are asking it is not about cost and all this. We are just talking about where is. So if I fix a j here, right? Where is nearest of sigma star of j? This is what I'm asking question.
Why can't this be I prime? But then this the difference would be 0, right?
If nearest of sigma star j is this I prime, yeah, this could be. This can this be? Think about it.
Means this itself.
Wait, because look Sushmita, sigma star nearest is defined in X. X does not contain I prime.
No, after the exchange, like
We are not talking about like its
okay, got it.
definition is here.
Definition, yeah, okay, problem. Okay, fine, yes. Okay,
Okay. Because that's the how we are doing mapping, because X is never changed.
yes.
So now let me ask, sigma star of J could be what?
It could be I. No, yes,
That
it could
is
be
the
I.
question, why it cannot
Saket, if sigma star j would be I, then this change in the cost would be.
It has nothing to do with the cost. Suppose sigma star of J is either I prime or it is not equal to I prime. Okay? Huh? Look at the sigma star of J. Either it is equal to I prime or it is not equal to I prime. If sigma star J is equal to I prime, then what happens? If sigma star J is equal to I prime, then it is in this column, right? And then I have assigned to I prime. I have no worry about this. So now look at the case when sigma star of J is not equal to I prime. Okay?
So now the question is why it is not I? Nearest is not.
You don't see? What was the swap? What was the relation between? What was the relation between I and I prime? What was the relation between I prime and I? Nearest of I prime is equal to I. Right? This is how we do it swap, right? Okay, fine. Nearest of I prime is equal to I.
Nearest of inverse. Function.
Otherwise, how did I decide whom to swap? When I was deciding this swap pair, right? So nearest of I prime is equal to. So now use this fact and tell me why it cannot be.
So by triangle inequality we can.
It's not about triangle inequality, Sushmita.
I'm saying that we can, if the distance with that case, I'm just trying to understand if j, that sigma star of j is not equal to I prime, whatever it is, its distance must be less than the distance between j and I prime. And the distance between I prime and that hypothetical nearest person is bounded. Therefore, I can upper bound the distance.
Look at this set of element. Is their nearest j this? No. So their nearest j is someone which is not equal to I prime. Nearest, not nearest, sigma star of j is not equal to I prime. So sigma star of j is not equal to I prime here, right? Now if it was a bijection, then it goes to someone else, right? Which is not equal to I, and that's it.
Okay, so it's not equal to I and it's also.
So look, I prime is paired with I, right? So think of this way. Here I prime gets paired to I. Now I am saying, look at this j, sigma star of j is either equal to I prime. If it is equal to I, if sigma star of j is equal to I prime, forget about nearest, I mapped him to I prime itself. But now So sigma star of j is not equal to I prime, so it is some I double prime, right? But because we are in the bijection case, I double prime is not mapping to I, no, I double prime is mapping to something, I tilde, which is not equal to I, and hence that element exists. Because I only deleted I from my X. Okay? So it is important that when we are doing our analysis, hello, let's reassign this to here and let's cause the sum. If that element is not even there in my current solution, what are you reassigning and what are you computing the cost? Right? You can only compute the cost to the object which is there in your current solution. So I said, let me delete x minus I plus I prime, and now I'm trying to do the analysis. And analysis, I said, for this, let's take, let's assign this to the nearest. That nearest is not even there, you deleted it. Then you are dead. Then that analysis doesn't make any sense.
So in the bijective case, only people who are getting reassigned are the people who are originally with I, and they will now be costed with respect to I prime. That's it.
Yes, but like we also have to make sure that.
Because it's a bijective case, all others remain.
Yes, I understand that. Yes, correct.
That's it.
But when it is not bijective.
Yes.
We'll get to that. No, this is exactly what I'm trying. So this is why, it is not, I'm saying, it is not only about this computation, it is also how we select these things, that these are not violated. That's all that I'm trying to tell. Right? So we have to be careful, otherwise this analysis wouldn't go through. I'm saying, look at this set, let me compute the cost of this set. This set, objects are not even there. What are we talking about then? Okay, that's all that I was trying to tell. Okay. Now, so let's do this bijection, and I will show to you that these two properties hold, and then this will hold. Okay. So now here is my x star, and here is my x. Okay. So let's partition them based on all these has at least two elements of x star mapped. Okay, have two elements of x star mapped. Okay, and these are exactly equal to 1, and this is exactly equal to 0. And why they will be 0? Because this also has a size k, this also has a size k. Is that fine? Okay. Now, what happens? So what I'm going to do, I'm coming up with an assignment. I'm coming up with a function, say g from x star to x, which will have some property. First of all, nobody maps to say x greater than equal to 2. Nobody will map to x greater than equal to 2. You understand? What it means? That whenever I do x minus something plus something, these elements will never be mapped, never be deleted. So for whomever it is nearest neighbor, it will stay nearest neighbor. Is that fine? If this element will never be swapped, right? I'm making a swapping pair. I say, what is my swapping pair? One guy delete, this is my delete, and some I prime, this is add. This delete element is never going to be from here. So it means in whatever computation, if I'm talking, look at his nearest neighbor, it will always be here if it was here. Okay, so that's one thing to remember. Okay, so this is one property I would like to have. Now notice, so nobody will map here, and here if someone is mapping here, they are mapping here. One I don't change. Now I have to decide, but now tell me, if both sides are k, how many elements are remaining here? Right? So if number of elements here that are mapping here is q, say q, then here at least it will be q by 2. At least q by 2 0 elements will be there. That's right?
Hello?
Yes, tell me.
Yeah, I'm a bit confused with this replacement. So what is I prime is any vertex in x star?
No, I'm telling you whom should I will change. I'm going to explain to you. I'm giving you pair whom to replace. For every I star in x star, I will tell you the replacement pair will be I star. So it will be g of I star comma I star. G of I star, delete, I star, add.
Okay.
Q by 2 or 2?
Okay.
Please think. This is also I did last class. So you should have checked it. These guys and these guys don't contribute, and each of these guys, imagine all of them, like 2 of them goes here, right? So they, for each of 2, at least 1 place is left here, right? So, okay. So what I will do is, I'll just arbitrarily, I say, look at the first guy here, map him to him. Look at the second guy, map him to him, right? Next, oh, your 2 quota is full. No. Let me put to the next element, map him to him. Like, so you just basically take 2 elements, assign it to first element, take next 2 elements, assign it to him, next take 2 elements. So basically after that what is happening is you are making a group of 2's, right? And each 2 is mapped to 1 element, 1 element, 1 element, 1 element. That's it. Is that fine? Okay. So this is my deletion process. But now look at the beautiful thing that happens. Okay? I'm going to delete this because this is not relevant. Okay. Okay. So let's draw our picture all over again.
If this color is not visible.
Oh, it's not visible? Sorry. Like, is it visible that it's not visible?
My
Yeah,
very
that's
light.
okay, fine. But do you see blue?
Yes.
Okay, fine. Okay, I will let's see if you can see green. Do you see this?
Yes.
Okay. Okay.
And that corner is also not visible.
Fine, fine. It is just like I'll just trying to tell you what happens. So now what happens? Now let's try to understand that if I put up someone from here, imagine, right? So I have a pair, right? So what is a pair? An element here, an element here, and an element here. So this corresponds to column, and this corresponds to row. So let's focus on this column, and suppose this is the row I am focusing on. Okay. So clearly, whom I will assign here? I'll assign everybody here to whom? To this element, right? Let's call this element I star, and let's call this element I. So this is ith row, this is I star. Now what were we assigning here to all these people? Huh? Yeah, nearest. Now look at a j here. Okay, no. Look at a j here. He is assigned to some facility, right? So look at his sigma star j, which is going to be here. Where is his nearest? His nearest can be here or here. His nearest cannot be here, no, because these were not assigned anybody. So those are here. Great. Right? Excellent. So no issues altogether. So if I'm doing an exchange with this, I'm great because these people are not nearest to anybody, though, so I'm very happy. Excellent. Okay. So the problem is when I do exchange here and here, but then this is a bijective exchange. The same argument as before will work, and then we're done. Right? So analysis and everything performs very still well because we are still assignment is to nearest, and then the same maths goes through, right? You understand? And now we have, so this is why we have to be careful what we are trying to do. If this element is not even there, then what are we writing? D nearest of this, then it is not a cost of this x prime, right? So that is what we have to be. So when I assign head, I know none of these elements are assigned here. So for example, if I would have been doing this flipping, okay? So now what happens? If I'm doing this flipping, then I know, suppose we are doing this, so this is I, so again we assign here,
Hello. Saket?
Yes.
So we are assigning two vertices to one person in this zero set, right?
No. So 2 elements in X star is assigned to 1 0 element.
Right.
Okay. So think of this way. So let me draw slightly better. Maybe that will help. Okay. So imagine that these are singletons. Okay. Okay. And like these are going to singletons, and this is say at least 2 people, and this is 0. So what I do, I make a pairs of 2 here, right? And I assign pairs of 2 to single element. So this is assigned to this element. This is assigned to this element. This is assigned to this element. And this element is not assigned to anybody. Is that fine?
Right.
Huh.
So when we are doing this I star and I thing,
Yes?
I star is part of this set of size 2.
No, I star is part of my X star. Look at this, X star. So what are these?
Right.
So I star is the optimum solution that is good. So I star is here. This is I star, and say this is I.
Now when we are considering this J,
Hmm?
then sigma star J might be in the same set which contains I star.
So look at sigma star J.
Okay.
Okay? So, so what am I deleting? I am deleting I only, no?
Correct.
Okay.
But if sigma star J,
Sigma star J is some element in X star.
right,
Their nearest is not mapped to anybody here, right? How did I make?
no, because maybe the sigma star J is in the same set. Which
It
contains
cannot
I.
be, no? So I started with the nearest function, right? How did it look like? Remember, this is my nearest function map, okay? So my nearest function maps looks like this. There are some set of elements not mapped by anybody, right?
Then nobody's near.
Wait, Sushmita, wait.
Not map means that. Right?
Yeah,
They don't-
right? And these are those elements.
Okay.
So those guys can, so this is exactly what happened. Okay? Okay.
Okay, sorry, so just one point. So the reason you never reassign anything to those x1 vertices is to just to preserve the bijective part. Like you
No,
are,
no,
you are
not
scared
be-
to throw things away from there, and then you will have.
Yeah, no, but if I assign them here, I could probably assign them here. First of all, I don't know their cardinality. That's one. How many of it could be everything is this, then I cannot assign to anybody here, right? Imagine that this is not there. So if I assign them somewhere here, my degree will like number of people.
You don't know the size there, therefore you don't know how many people will be taking.
Yes, so first of all, this degree could be unbounded, so I don't want. This is the reason why I'm not assigning to anybody here also, because degree of these people are very unbounded. Because imagine that a situation that everybody maps to this place, then we will get a very bad factor approximation. So by removing this assignment to here, I have said, let the bad guy not determine my fate. Okay. So imagine now that I'm mapping this. So this is my I star, and this is I. Okay. Now this is perfectly fine. Look at sigma star of J. Sigma star of J is here, then that's perfectly fine. Okay. If sigma star of J is here, then it cannot be I, because it is someone else I prime. So you have mapped to someone else. Then you are done. Okay, that's it. So that's all that the whole analysis is. Expecting just teachers to go and work hard and like a student just being listener is not helpful. I mean it in a very honest way. Otherwise, this course will be like no utility to you. You will never be able to use it ever in your life again. Right? It will be like a distinct memory as you go forward in just 2 months. At least be respectful of the teacher. This is not my area of research. For each lecture, I have to work hard, prepare, and come and deliver. At least have some respect to the teacher. At least be prepared. At least see what it is. If it is difficult for me, it could also be difficult for you. So how hard it is to at least have a look and then come to the clause. Okay, so we'll do 1 or 2 more examples and let's see how we go. So okay, so this is last problem for which we will see local search, at least for time to come. Okay, and this problem is called okay, max to sat. Okay, so now we will do for max to sat. Okay, so what is the max to sat? That you are given okay, so you are given some phi, some x1 or x2 and x2, x3 bar, x4 and okay, and something. Okay. So every clause will have two literals, okay, and distinct. So I am not allowing say x1 or x1 bar kind of thing. These are not allowed. Or okay, so like everyone is a like real good this thing. And what is my goal? My goal is to find an assignment. Okay, find an assignment. So suppose it is over variable x1 to xn and say x is this. Find an assignment to x bar, like, and what is an assignment? Assigning variables to 0, 1 such that number of satisfied clauses is maximized. Is that fine? Okay. If I give you a 2-sat formula phi, can you test whether it is satisfiable or not? Yes, no? Is it a knowledge or you know an algorithm? Okay, how many of you know this algorithm? Okay, anyway. So, okay, anyway, I don't need for my algorithm, so this is perfectly fine. Okay, but this is polytime and it has actually linear time algorithm. Okay. So I am going to, but our job, but this is NP hard, to finding an assignment which maximizes the number of clauses. This is NP hard. Can you tell me? Can you tell me why it is NP hard? Can you give a reduction from max cut? Yes, no, maybe. Okay, anyway, think about it. Okay, so now what I am trying to do, so we need a, so this is hard, so we need to make a, we will try to design an approximation algorithm for this. So what do you think could be a procedure, a local search procedure for max set? So of course it takes formula phi and it will output something, okay. So what should be the, what is the first step of algorithm? We start with a solution. So what should we start with? Start with an with an arbitrary assignment. Arbitrary assignment to say x equal to, I think, I mean, how do I am going to use capital X to denote this. Okay, I start with an arbitrary assignment. Now what should I do? What should be my local swap?
Which satisfied at least half of the.
Why? Okay, so tell me how will I find half satisfied?
An arbitrary assignment, either it is less than half or greater than half. If less than half, then it's complex.
Okay, fine. So you can also do that. Perfectly fine. So start with an, oh, you can start with that, but I will not start with that. Okay, but you can start with any clever assignment and you can start with that assignment too. Okay. So what is my swap? What will be my local search step? Right? We also need a local search step. So what is my local search?
Unsatisfied clause.
What?
Pick an unsatisfied clause
Mm-hmm.
and then pick an arbitrary
We
literal.
may change one other satisfied one.
But that's okay. No, let her try. No, whatever she is trying.
So we look at this assignment and pick an unsatisfied clause
Fine.
and then
Try to satisfy it.
by picking one of the literals.
Okay. Yeah. So I could satisfy this, but that could.
But then I have to check if the number of satisfied clauses is not decreasing.
Yeah. So fine. So rather than doing that, I could say while true, we do the following. Okay. If there exists a, what do you call it, a literal, which if we flip, okay. Okay. If there exists a variable xi such that if we flip such that swapping its value increases the number of satisfied clause, do, then flip. Is that fine? That's it. Then do, else break, right? And you can return x. This one, right? So this is my, is it polytime?
You are asking while loop will run.
Yeah, so is this algorithm polynomial time algorithm? Yes, no? It is. Why? Why it is polytime algorithm? So all of you say it's a polytime algorithm. So my question is, why it is a polytime algorithm? Yeah. So the while loop will only run at most m times, where m is the number of clauses. Okay, and then of course you can check all these things in n plus m big O of time. So this is poly. So this is perfectly valid. Okay. So what is the third thing we say? Okay. So now at this point of time, so all I know, this correct assignment, I flip anything and something goes wrong. That's all that happens, no? So what is this? So now what can I deduce because my swapping algorithm does not work, right? So what is the property of local optimum? So property of local optimum will be what? So flipping any xi does not increase the number of satisfied clause. Is that fine? Right? So if look at some xi, look at some variable xi. At this point of time, it is satisfying some set of clauses on its own. Okay? And when I flip, it will unsatisfy and satisfy on its own. Okay? I'll tell you. Xi, so I'm saying fix some xi, and I'm saying what is ai? Set of clauses that xi is responsible for satisfying. Okay? So let me write down what I mean. Okay? So for example, if you have some clause like this, so what will ai consist of? Suppose xi is set to 1, then ai will consist of all those clauses xi or beta where xi is set to 1 and beta is set to 0. But then who satisfies? It is not the beta who can satisfy this. It is, and it is, so beta as a literal is set to 0, xi as a literal is set to 1. So this is the one who is responsible for, right? And similarly, if xi would have been 0, then it would have consisted of xi bar or some beta. This literal evaluates to 0, and because you have set to xi, so this is the responsible clause. Is that fine? Right? So, huh?
Because xi is set to 0 and
So if xi is set to 0, xi bar is set to 1, and beta as a literal is set to 0. So why is this clause satisfied? Because xi has been set to 0, right? So if I say set of clauses that xi is responsible for satisfying, means it is he who satisfies, right? If I decide to change its values, this is going to change. Okay? Is that fine? Okay. Now, what can I say about two distinct sets? For I not equal to j, what can you say about ai, aj? Intersection is empty. What are you not able to understand? What it means? By definition, this is a, look at a clause. This guy is responsible for satisfying. This guy is. But what does ai, aj doesn't count? All those clauses which are satisfied because there are two people who are set to true. So what is implies? It means the algorithm, number of clauses satisfied in the algorithm is definitely at least summation ai. I equal to 1, n to n. Alg is number of clauses satisfied by x, by this x which is local optimum. Yes or no? Because there are some clauses which is not in any ai because it is satisfied by two variables. So at least this much.
so if this ai intersection aj is empty, I don't understand.
What is the definition of ai? xi is response. Look at a clause here.
But if a clause has two, as you said, it has two literals.
Then it is not neither in xi, neither in ai nor in aj.
It still go into only one.
No, it is not going to anybody. Read, no? This is why it is at least. The clause edge which is satisfied because both of its literal is helping him to satisfy, I don't even bother about those clauses. Right? This is why all is at least this much. Okay?
So ai's definition is that only xi is responsible.
That's exactly. Set of clauses that xi is responsible for satisfying. Right? Nobody else. If there are two people who are, I say let's not bother about them. Because when you do local changes, right, those are the clauses with just one flip, those clauses are not going to change, you know. You understand why I'm talking about ai and not those? Because if imagine that two variables are satisfying it, right? So if I just flip one, that guy was satisfied before, it will remain satisfied now. it's not the question of later. I'm only talking at this point of time when my local search. So those are not the one which is going to make any change. Okay. Then what happens if you flip? AI is going to, the responsible, if I flip xi, definitely AI will be falsified. Right? AI will be falsified. But there are possibilities that some clause will be satisfied. So let's try to get that quantity also in. Okay. So what is BI? So we now that we have BI, so what is the BI clauses? Okay. It is those clauses C contains xi but evaluates to false. Is that right? So look at this. What is my BI? Those set of clauses that contain C but currently it is evaluating to false. Right? What happens if we flip xi? All these clauses will be satisfied. Okay. But it is a local optimum, right? So local optimum. So what can I say? For all I, what is this? What can I say? Huh? It is less than equal to, because even at equality I don't flip. I only flip it is strictly increase, otherwise there is otherwise we will in loop. Is that fine? Because if this would have been more, strictly more, then I flip, I unsatisfy this much and I satisfy more, which is strictly more. Right? Okay. So what am I interested in? Okay, so summation bi I going from 1 to n, summation I going from 1 to n. Is that fine? Okay. And this is less than equal to alg, right? Because alg is at least this much. So alg is greater than equal to this quantity. So somehow we have to understand what is this quantity, right? What is this quantity? How many clauses are satisfied in my graph? How many clauses are satisfied in this? Or how many clauses are unsatisfied? No, m minus algorithm. This is number of unsatisfied clause. Is that fine? Right? And each unsatisfied clause comes into how many sets of BIs? Each, look, m equal to alg is number of unsatisfied clause. What is left hand side? Look at a clause, it is unsatisfied. It will occur in, suppose you have xi or xj and it is unsatisfied. This will belong to bi as well as this will belong to bj, because bj C contains xj but evaluates to false. So what is left hand side then? It is 2 times m minus alg. So are we getting something? So this implies algorithm is at least 2m, yes, 2m by 3. Is that fine? Excellent. Okay, so this was the most, okay, is it fine? So we are done. Okay, so this is a factor 2/3 approximation, but this actually tells us that, hey, this algorithm is going to find an assignment that satisfies 2/3 of clauses for any this thing. Now we will try to improve this, and this is where the idea comes of what is called, which is the most very unintuitive, but what is called non-oblivious algorithms, okay, or non-oblivious local search. Okay. Okay. So what I mean by non-oblivious local search? Okay. So imagine that I could associate a potential to my algorithm. Okay. What I can do? I can associate a potential. Associate a potential some phi and say, hey, please make a swap if potential strictly increases, right? But that potential need not be something which is obvious. What is the potential we are used? We said
Same as number of clauses.
currently, right? This is the current potential, right? So I could have rewritten this algorithm. I said, hey, if there exists a variable xi such that phi of some flipping increases compared to something, x prime is greater than or equal to phi of x, do the flipping, right? So here is phi of x is the most natural definition that we can come up with for this potential. But there could be very unnatural potential function that we can come up with, and we can say, hey, let's try to increase that and then see what happens. You understand? Okay. So we will try to do that to this algorithm, and algorithm will remain the same, but the potential will change. Okay. Is that fine? So this idea of something unnatural potential that you assign to your local search algorithm, and you try to improve that potential, or it's called non-oblivious, right? Because it's not obvious what you are trying to do. So it shouldn't be called non-oblivious, it should be just called non-obvious local search algorithm. But I am not the one who defined it, so okay. Okay. I don't know why it is called oblivious, but we'll call it.
I think it's because you're adapting it, non-oblivious in the
Correct.
sense of adapting.
That's right. Okay. So what is the, so we are going to have the same algorithm. Nothing is going to change the algorithm. Okay. So I will say, if there exists a value, says swapping its value increases the potential, then do. So what is the potential we are going to assign? So this is procedure max 2 sat non-oblivious local search. Okay. I have no clue why people have come up with this, but maybe when someone does analysis, okay. So the potential function, to define potential function, I will define some more quantity. Huh? We'll see. So given this x, I'm going to define some quantity. Okay. So what I'm going to define? Okay. So n0 of x, n1 of x, and n2 of x. Both literals are negated by x. It means, so what is x? Number of clauses where both literals are negated by x. n1 x will be, okay, exactly one literal are negated by x, no literal are negated by x, right. So basically it is those clauses which are satisfied because of one variable. This is like AIs. And what is n2x? It is those where both of the people are making. And what is n0x? Are those clauses which nobody satisfies because both literals are set to negative. Is that fine? Okay. So what is my phi? So what is number of satisfied clauses is? Tell me. What is number of satisfied clauses? n1 of x plus n2 of x. And this is the potential we used before. And now we will use a different potential, and that potential will be called phi of x is 4/3 of n1 x plus n2 of x. That's fine. Yeah, 4/3 of n2 of x plus n1 of, oh no, this is n1 of x. Yeah, right?
Half of n2x makes sense. Both participate.
No, it makes a lot of sense. No, but it is why it makes sense because
Half of n2x plus n1x will responsible for making this clause satisfy. So
Or rather think of this,
So
no?
half
So this, no, why half? So it's like, imagine that many people make me, so I don't even bother about it. So like these clauses will survive for more rounds. So they have more potential.
No. So with these, in the potential, we want to see how fast the conversion, like
No, it is not, it's not about convergence only,
No,
right?
convergence-
It's also about quality of solution, right?
so we want to measure the difference between phi x, like the
Yes.
step-by-step difference,
Yes.
and it should tell me it is high. It means this particular change will lead me to more number of clauses being satisfied.
That's right. No, it's not more clauses. Is the potential increases or not? That's it.
Yes, so that would mean it's a good path to that. This is the way we should set the variable, right? That is.
It is no path, no, Sushmita. There is no. I like if I don't know, I could go into any order and I try to fix if my some.
If you have the difference between phi x from step 1 to step 2 is large versus another possibility where it is smaller.
But I'm not. I'm doing any arbitrary thing, no here.
Yes, but when you're doing arbitrary thing, it tells you that each step how much progress you are making.
It is not telling me this is exactly what I'm trying. It is not because it is not telling me any. It is not even talking about any progress at this point of time. Because I'm not trying to magnitude, right? It's not about progress, right? Because I can go back and forth, back and forth, back and forth.
No, that's fine, but each step you're trying to measure how many clauses would be satisfied.
No, I'm not measuring that. That's exactly what I'm saying.
What is n1x? Number of clauses.
Yeah, it is like 4/3 of the some number.
No, n1x the value.
The number of satisfied clauses is n1x plus n2x.
Sure, n1x tells you the number of clauses that are satisfied by.
One variable.
Okay, and the n2x is telling you the number of clauses that are satisfied. So, what is delta phi of x? Phi of x from step 1 to step 2, the difference will tell me what exactly that
I have no clue what they will tell me.
is. It will tell you how much those values are changing.
No, what do you mean by how many values are changing, Sushmita?
Okay, let's write and we'll see.
No, it is not like what do you mean by values of what?
The n1x from. So,
Of course, that is like, but that is not telling me exactly the number of satisfied clauses, unsatisfied. It is some number that has been associated, right?
but if that is positive. If
That other by no. So I'm saying, what is the problem? I also used the old potential, right? Which was n1 of x plus n2 of x.
Yes,
Yeah.
you're giving equal weight to this.
It-
Over there, you're giving a different sort of a weight.
Yes. Yeah.
So I'm just, okay. Let's do the analysis. Then I'll ask the question in the context.
I'm not understanding the question.
Okay, no, right. Let's do the analysis. Then I'll ask.
Okay, so what I want to say, so now I want to, the way I define the sets AIs, so I fix a variable xi and I want to understand the sets AI, I will make several sets BI, CI and DI and they will mean precisely what they are supposed to mean. Okay, so what is AI? No, so let's say that now AI will be where both xi and clause C where both xi and other variable is set to true, right? So this will be like, this is like n2x. With respect, all those clauses where xi participates and other guy is also satisfied. And what will be bi? Bi will be, okay, xi evaluates to true, but other. Okay, then if you want, I can make. Okay, so if you want, because okay, it's okay. Xi evaluates to true, but other variable is set to false. Okay, Ci xi evaluates to false, but other variable is set to true. And what is di? Both variables are set to false. Please ask, you have any question? Xi evaluates to false, but the other variable is set to true.
But CI and BI are
look at AI, look at all the set of clauses, right? Look at all, both xi and other variable is set to true. Look at all the clauses where both guys are set to true, and among them pick up those guys which were here xi is fixed, right? Xi, it is not about ai is defined with respect to variable xi. It is not with respect to anybody else. Of course, I cannot distinguish otherwise. It is only defined with respect to this. Okay, so I just want to understand what happens to the potential when we make changes. That's it. Okay, so I want to understand what I know about phi of x and say phi of x prime, and what is x prime? X prime is where I flip the assignment of xi. No, I only want to fix, not keep xi. Okay. Huh? I mean, what do you mean by capital X?
Capital X is the full assignment of
Capital X is just 0, 1 some variable.
Full assignment of all the variables, of which small xi is 1.
Okay. So now let's try to understand what will this phi of x minus phi of x prime will mean. Okay. So what is phi of x? Okay. I have only flipped this. So if I flip this, wait. So there are other clauses. Let's call it delta are a set of clauses that xi does not participate. Okay, there are some set of clauses which xi doesn't even participate. Okay, and they are satisfied by x. So these are the clauses which will have absolutely no bearing on my satisfaction. You understand, right? And notice, okay, number of clauses. So what I can write, so what is phi of x? I can write my phi of x equal to like plus some function of delta, some 4/3 this and that, I have no clue, plus something here. What is that? What can I write here? Look, ai, what is this? 4/3 times ai plus xi evaluates to true, but other variable is set to false, right? So this is bi, and what is?
No, DI was calculated earlier.
Huh?
DI is
What is bi?
DI should be in delta, right?
Why? xi evaluates true, but other variable is set to false. By definition, that xi does not participate into, not participate, xi does not even occur.
But your that phi function does not contain any delta type term, right, over there? That's
No, like it contains, right, n0x number of clauses which is satisfied n2, n1x.
yeah, but n0 is not part of the phi.
Yes, but it is n1x is there, right, n2x is there, but n2x is satisfaction with respect to the x.
Yeah, but what is your n2x? N2x isn't n2x equal to ai exactly?
No, ai is a fixed set of variable
ai is a set of clauses.
which contains xi. Yeah, but that is not. There could be clauses. There could be clauses which does not contain xi. They could also be satisfied, right?
But then why they won't participate on those n1 small n1?
Yes, that is what is f delta. No, I have removed them, and I'm saying I don't know what is 4 third and all this is. That is what it is.
What have you written n1x to be over there?
Number of clauses where both literals are negated by x. n1x exactly one literal are negated by x. n2x no literal are negated by x.
So shouldn't n1x be exactly the same as b1x, bi, this cardinal?
Please see why it should be just not BBI.
Isn't that a clause?
Imagine what is A1, where both variables are set to true. A2, A3, A4, all this is going to contribute to that, right? no literal are negated by x. These sets are only defined for variables clauses that contains the variable xi.
So no literal is negated by the over there capital X you're using, so the assignment capital X, right? So no literal is, so n to x are all those clauses that contains literals that are that are set to true in the capital X assignment. So n to x over there, that definition n to x contains all those clauses
Yes.
which contain variables.
Both.
Yeah, both of whose variables
Are set to true.
in that assignment capital X.
Yes.
So I see. Therefore, they are participating in the delta phase.
Yes, because this is, I'm only talking about clauses that contains the variable xi.
Yes, fine.
Tell me, boss, what's the problem?
Yeah, that is with respect to the entire assignment.
What's your question?
Capital X, this is X.
I was guessing what will be bi plus ci minus di.
So we'll see now what it is, right? We'll see what it is, right?
My question.
So I'm trying to write this. It is 4/3 of ai plus bi, right? Both with respect bi and xi is set to false, but their other variable is set to true. So what will I get here? Will I get ci? Okay. Of course, di is not going to contribute, right? Plus function of delta, which is like all those clauses which they are also going to contribute. What? Yeah, because that's not. I mean, look, it's not about that. Like, they does not occur and they are satisfied by x. There are other clauses which does not contain the variable xi. Those contribution, I'm just going to write it this. If you want me to write it, I can write it properly. But this is like some number which is like some function. Now look at phi of x prime. What happens to phi of x prime? Both xi and other variable is set to true. Now what happens to this now?
Again 4/3 of because it change between remains 30.
Wait. It becomes 4/3 of ci. What is ci? xi is set to false, but other variable is set to true. Now ci takes a role of ai in this. Okay, and now what happens? Wait 1 second, Sushmita. Now, although I'll just give me 1 minute. What happens to ai? What is the role of ai now? So that is ai.
And bi becomes
What is ai? Is exactly one guy will be set, because this you have changed it. So this only one guy is set, right? Okay. Now what happens to is set to bi becomes
unsatisfied.
unsatisfied. So bi goes away. Okay.
And di remains, delta remains the same.
And what happens to
Delta unaffected.
no, but di also you have to add. Okay, and now I am interested in what I am interested in is phi x minus phi x prime. So what will I get then? Is equal to, if I do now, I will get 4/3 of what will I get? 4/3 of mod ai minus ai. Is this quantity correct? Is this quantity correct? 4/3 of ai minus ai.
That's one term.
Okay, and then the same thing should hold for
The flip way ci, but the other way.
plus. Wait. Plus bi. Nothing changes. Okay. Wait. Is this okay? Okay. And what I know about this? What is the potential? Why am I not? This is greater than 0 because this is less. So we know that this quantity is less than 0, otherwise local search would have applied. So now this implies for all I between 1 and n, what can I say from here? Right? So I can say here mod ai minus ci by 3 plus bi is greater than equal to di. That's it. Is it fine? Okay. So what is the total number of satisfied clauses that algorithm returns? Algorithm returns how much? Algorithm returns n1 of x plus n2 of x. Is that fine?
What do you mean algorithm returns?
How many clauses is satisfied by this algorithm? n1x plus n2x. It is not about potential, right? Algorithm returns that many satisfied clauses. I want to understand how all these things were related. Okay. So now what I am going to tell you is so now I am going to understand each of these terms when I do summation, and I will do everything. Okay. Okay. Now let's first try to understand the term. What is summation di? What is this? Both xi and other variable are set to false, right? Both xi and other. So basically, what is summation of di? So every clause which is unsatisfied is going to contribute to this, and how many times? 2 times, because both variables are set to false. So this is equal to 2 times m minus algorithm. Is that fine? Every like what is summation of di is basically look at an unsatisfied clause. Why it is unsatisfied? Both the variable, like both literals of that clause is set to false. That is precisely d. And how many such clauses it is going to contribute? To 2 such clauses, right? Here. Think of this way. These are the clauses which are unsatisfied, right? And this is my variables, right? Why it is not exactly equal? Because this is exactly equal to this, no? It is. So this is why every clause contributes to 2 DIs.
Okay, so m minus alg is actually the number of clauses that are left unsatisfied by my algorithm.
Yes.
And therefore, twice of that many will be the summation of DIs because each variable is contributing.
Not each variable. Each clause is
yeah,
contributing to 2 DIs.
Yeah.
This is exactly it is. So if I write these clauses and you write these DIs, it is exactly each clause will contribute to 2 DIs. So then sum them up. Okay. Okay. So now what else is left? Okay. Can I say summation I equal to 1 to n bi's is equal to summation I equal to 1 to n ci's? Huh? Why? Because what is xi is evaluated true, but other variable is set to false. This is bi, right? Xi is set to true, but other variable is set to false. And what is ci? Xi is set to false, but other variable is set to true, right? So you count from this side or count from that side. So this, but what is this equal to? What is this equal to?
This is part of the
Huh?
satisfied.
This is exactly equal to n1x. Okay. And now summation I equal to 1 to n. What is ai? What is ai? Both variables are set to true, right? So this is basically no literals are negated. So this is n to x, but each clause contributes to 2. So it is 2. Okay. So now if I sum this inequality, I going from 1 to n, ai minus ci divided by 3 plus summation bi is greater than equal to summation di, right? This is what I will do. I will get if I sum for, right? So, what I am getting from here? So, okay. So, now basically what I am saying is that look at this inequality and sum it up. Look at this inequality and sum from I going from 1 to n. If I do this, I am going to get ai minus ci divided by 3 plus summation going from I to n bi is greater than equal to summation I going from 1 to n di. Okay. Now, what is this? Summation a. So, if I take 1/3 common, what is summation of I equal to n ai minus ci? This is 2 times n to x minus what? What is this? Okay. Oh, ci, right? Okay. Plus summation bi is also n1 x, which is at least how much? 2 times m minus alg. Okay. So, what are we getting? So, if I do this, what am I getting? Will I get something? 2/3 n2x. So, plus 1/3, right? Because from here. Okay, wait. Okay, so this is 2/3 of, it is alg. Why are you making noise? Oh, okay, so if you say, is right? I can do this maths. Okay, so this is a non-oblivious local search algorithm for 2 sides. So I think it's just people just work out and then do some of these things. Like I have no clue why will someone come up with this kind of measure. Okay, any question?
It means adaptive, meaning you are looking at what the effect is and then making a
Doesn't matter, no, whatever name is. Let's call it non-obvious local search.
oblivious.
No, I call it non-obvious local
It
search.
is also non-obvious, yes. Okay, so my question was, if at the step where we are just resetting the value of xi, smaller variable, phi of x minus phi of x prime is just one variable
Yes.
flipped. So the difference between phi x and phi x prime tells me the benefit I get by flipping the variable xi. The benefit or the
Look,
disadvantage,
Sharmita,
depending on the
oh, look, wait.
value change.
I agree. If I would have cared about, okay, let's flip the one which maximizes this.
No, I don't do that because in a way it's like just one value doesn't, look at the way things are affecting. Like the set AI is becoming CI and so on and so forth. So there are other variables also whose
Yes, but then
values have an effect.
but
on
then phi x minus phi x prime is not telling me anything, right?
phi x minus phi x prime is just telling me what flipping that xi will give me.
Like all I care about,
Everything else remains fixed.
I understand that, but that's like that also told me before when I said phi x and phi x prime. That's exactly what I cared about.
Sorry.
Look, before also I only cared about phi x and phi x prime. That's exactly what I was doing before also, right?
Yes.
My phi x was number of satisfied clause.
Yes.
So what difference does it make?
here you are taking a more refined, you are literally
I understand,
saying
but
that
like
how
why?
you're
Why? Like why it is why it is giving me a better bound? I have no idea.
because you are seeing how the presence of the other variables might also, the
In the
only time-
algorithm, I am not taking any advantage of any. Algorithm is exactly the same. It's just some potential.
Yes, the analysis tells you that this approach actually gets you.
It is no approach. No, algorithm is same. That's exactly what.
No, this analysis tells you that the algorithm is performing better than that root proposed, the worst case analysis that you were doing.
Yeah, but that's exactly what I'm saying. That like, then I have absolutely no clue by looking at it that why should I be setting it? I have like
That is okay.
I mean like okay, why this potential? Why that potential? I mean, there's absolutely no clue to me.
People work